Thank you for the invitation to speak here in Seoul. And greetings from Sweden. We have spring and it's really nice weather here. My name is Marco Granroth. I'm an inspector and design team leader at Sweco. Today's topic: design and engineer coordination using BIM. Sadly, I cannot attend personally. As everybody probably has heard, we have some problem with the flight due to volcanic activity. We were asked to make a film instead of live presentation. I will have a short presentation of our company. After that, I wish to share some experience we have gained since November 2008. It's something I have seen before but never tracked. It has to do with collision detection and variation orders. We also track the 3D coordination model, how big it will grow, and the contract, to understand more about the limitation of software and hardware. I have also tracking the workload in the project from November 2008. All this new information has given me a different kind of topic to think about. It has to do with project management and cost influence curve. I wish to have ambient discussion and I hope you can take the discussion home to your company. And next time we meet, we can have a bigger and broader discussion. How should it look like? Sweco has more than 100 years of experience. It was created 1889 by Hugo Theorens. It has an international presence. It's in 100 countries since 1903. Areas of operation: water and environment, energy systems, infrastructure, building services systems, industry, structure engineering, architecture, project management, geographic IT. That is some of the areas we work in. Our vision. Welcome to Project Evert. This is our experience about collision detection. We have worked with this project since November 2008 and are still working with it. The project is located in Northern Europe, the beautiful country of Sweden, Stockholm County, and the area is called Sickla. Every project needs a team. This is our design team. Here you see the foundation of the building. The picture is taken summer 2009. This picture was taken 8th of April. On the right you can see the project manager Viktor Tchaikovsky. In the middle you can see me, Marco Granroth. And on the left you can see Bosse Pettersson, who is the installation coordinator on the site. Here we can see one side of the building. If you wish, you can go on this website and see a live picture of the building. In the Sikta project, we have made 3D models in the architecture area, the structural engineering. The structure coordinator has delivered the 3D model, landscape, air treatment, heating, cooling, electricity, control, sprinkler, and then we have made special 3D voids to coordinate all the voids in the project. Here we can see the architectural 3D model that we use, the structural engineers 3D model, the structural contractors 3D model, the landscape model that we use in 3D, air treatment model in 3D, heating and cooling model in 3D, electrical and control model in 3D, the sprinkler model in 3D, All these 3D models help us in the design phase, how the building will look before it's built, and the contractor will use the same models on the site. One thing we don't show here is the 3D voids. It helps us communicate where the voids are going to be. These 3D voids has helped us with the structural engineer and structure constructor to explain what is our intention, and it has decreased the cost in the project. The Sikla office building is 22,500 square meters. But what about the size of these 3D models? The architect model 175 megabyte. Structural engineer 44 megabyte. Structural contractor 208 megabyte. Landscape 2 megabyte. Air treatment 36 megabyte. Heating and cooling 48 megabyte. Electricity and control 74 megabyte. Sprinkler 55 megabyte. Let's see how much is together. Remember, there are many disciplines still that makes 2D drawings. This is only very few of the 3D drawings, perhaps one of the importance, but totally it's 642 megabytes. If we put it in AutoCAD, it will crash. We need a supercomputer. That we don't have afford to use today, so we need a new or different kind of software to handle this, for this 3D coordination and tracking. Let's see what happens if we can use a different kind of software where we can 3D coordinate all the models. The size of the model in Navisworks that we have used is only 53 megabytes, but it's still too high, and we get some kind of problems with graphic card and hardware. I have been talking about other monies and ambient discussion, and it's always about money in the end. How much is the error costing? We can see that the error in a Swedish project cost about 4.5% in design phase. A good project 2%. We have seen in our project, the last one, it was 17,500 squares, that we have 10 real variation orders. That is very few. We calculate and estimate around 300 in normal cases. Few weeks ago we started to purpose the contractors for mechanical, electrical and plumbing. We asked the contractor how much they usually estimate the error when they estimate the cost. It's about 10 to 50%. So if you calculate with 10 million, 1 million, 1.5 million is error, variation orders. In normal Swedish project, it should be 4.5 or 2. The contractor asked me how much do I believe in this project the variation order should be. I said you should probably calculate around 2%, but I believe it's 0.1. Then we show the 3D model at the building site, and we show that we have found about 1,200 possible variation orders, and the contractor could go to the computer and look for himself and see the quality of 3D models. Purpose with this meeting was that the contractor could see the quality of the contract and get input to the project, what the contractor was thinking about our drawings and the quality. That is one way to get more correct price from the beginning in a project. I have seen different discussion about how big the models are, how the workload is, and how is the typical contract in size. This is a model I have created from our project Evert. Here we see the early stage of concept design, general design, detail design, Construction on the building site. Starting to buy the contractor. Timeline. Here we can see how the 3D coordination model is growing in time. This is an example of workload for mechanical, electrical and plumbing. Is estimated about 16,000 hours in this case. Here we can see the typical contract in PDF and size. This is the concept stage. Here is more words than drawings. In early December 2008 we started to make some simple drawings. At concept stage we don't use so much 3D objects. That is why the 3D coordination model is small in size. In general design we can see the 3D coordination model is starting to grow. We start to use object-based models. Here we can see from the beginning of general design it has grown from 0.3 megabyte to 7 megabyte. Here we can see in detail design that the files are getting bigger, 10, 16, 24, 43 megabytes up to 47 megabytes before purposing the contractor. Same way we can see also the working load is increasing all the time. But the typical contract is almost the same all the time. I think one thing is important is look at the working load and how the file, object-based file is growing. We can also see that the 3D coordination model is still growing. It has to do with the tendency. He wants to make changes in the floors. That means new variation orders has to be tracked and taken away before the drawing goes to the building site. This is one way to track the collision detection and possible variation orders. Timeline. Possible variation orders in the design stage. Typical approach of collision detection. Here we use the latest tools to track the collision detection and possible variation orders. Here we see the workload. In early stage we don't have so many drawings, so we don't track any collisions. A typical approach is to see the collision, discuss it and change it. We don't track them. As soon we start to use object-based tool and coordinate them in one tool, I think it's important to start tracking the possible variation order and the collisions. This is one way to show the customer the quality of the project. At the same time, the project manager gets a tool that shows the quality in the project. As design team consultant, we can track and monitor our own quality. We can both monitor the workload and identify the possible variation orders. But as soon we make a design change or a tendency change, of course we'll get a new variation order or collision. When buying the contractor, there should be zero collision. But there will always be a collision. Not 10 to 15%, not 4.5, not 2, perhaps 10 to 20 variation orders. In normal project, there always happens something in the end when you start building. There will be new collisions, new variation orders, but hopefully less than normally. Let's backtrack. This is optimized approach with the virtual model. This shows how the 3D coordination models grows, the working load and the typical contract. I think it's an important picture, especially if you're a project manager. The other one is collision detection. I think that is one too. How to monitor, how to work, how the workload is changing. I think it's important to understand these two, but there is something more. What about the cost influence curve? I wish to have an ambient discussion. I see it's changing. We have a typical approach with 2D. Now we go to object-based. Many of you recognize it. Even I. But we don't discuss the workload and how it's going to change with BIM. This is how it usually look. This is the workload in the project. And we discuss the cost of construction and cost of influence. But it's changing. It should change. That is what I feel. But how should it change? I think this change is going more to the left if you're going to have the same picture. The new curve, workload curve, should look like perhaps this. This is more what I believe in. We have to work more and harder in the beginning. Make harder decisions. If we don't do it, we will have problems. It will be very expensive in the end. Let's stop for a minute. Let's be quiet. Rethink. How should it be? How is it in your project? I believe if thinking big and working traditional, it will be very, very expensive in the project in the end. Before, if the architect made a change, it took 5 minutes for us to make a change. Today, if architects make a change in 5 minutes, it doesn't take 5 minutes. It takes hours with object-based technology. Late decision in the project will cost a lot of money. If somebody says, fast track, yeah, it's okay to fast track, but we have to change the working load. Decisions has to make earlier, and we have to understand. Changes in the end will cost more with object-based design. We cannot wait for the decision from the tendency. We cannot wait for the decision from the architect. We cannot delay the work. We have to start working earlier. We have to have good contracts in the beginning. Somebody has to pay for more expensive project. I believe this is what happens in a real project when you are thinking BIM but work traditional. Should we rethink? How should it look like? I know it's going to be more expensive thinking BIM working traditional. I believe in this, and I hope we can have an ambient discussion about it in the future. 감사합니다. Thank you for listening.